Did you know 1 gram of nuclear fusion fuel produces energy equivalent to 8 tons of coal? Moreover, coal releases billions of tons of carbon dioxide into the environment. But nuclear fusion produces a huge amount of energy with minimal pollution. This makes it an environmentally friendly fuel. In this video, we will explore how nuclear fusion fuel can revolutionize energy production. What is nuclear fusion? Nuclear fusion occurs when two light nuclei fuse together. For example, when two hydrogen nuclei fuse to form helium, a tremendous amount of energy is released. This is the same process that powers the sun and other stars. If we take a closer look at the sun, it is mostly composed of hydrogen with temperatures around 15 million degrees Celsius and pressures exceeding 100 million times atmospheric pressure. At lower temperatures, hydrogen nuclei repel each other. However, the sun's extreme temperature and pressure force the nuclei to collide and fuse. First, two protons fuse to form deuterium, releasing a positron and a neutrino. Then deuterium combines with another proton to form helium-3, releasing large amount of gamma rays. Finally, two helium-3 nuclei fuse to create helium-4, along with the two protons and even more energy. This chain reaction continues, producing a vast amount of energy. This process is known as nuclear fusion. History of nuclear fusion energy. The concept of using nuclear fusion for energy isn't new. In 1920, British scientist Arthur Eddington first proposed that stars generate energy by fusing hydrogen nuclei into helium. In the 1930s, Hans Bethe introduced the proton-proton chain reaction model. And by the 1950s, the first nuclear fusion experiments were conducted, in which two main approaches were used. First is magnetic confinement, using powerful magnetic fields to trap plasma, achieving the pressure and temperature needed for fusion. Second is the inertial confinement, compressing fusion fuel with lasers or particles. This led to the development of the first nuclear fusion reactor, the tokamak. Later, the United Nations developed the National Ignition Facility, using an inertial confinement system. In 2007, the International Thermonuclear Experiment Reactor calibration was formed to produce energy through nuclear fusion by 2030. In 2010, NIF achieved energy output greater than the input energy for the first time. In 2022, researchers at Lawrence Livermore National Laboratory produced more energy output than the input energy. Some private companies such as TE Technologies and Halion Energy are also working to develop nuclear fusion reactors. Challenges in developing nuclear fusion reactors. High temperature and pressure. Fusion requires temperatures exceeding 100 million degrees Celsius to overcome electrostatic repulsion, along with extremely high pressure to keep nuclei close together. Technological challenges. Current approaches like magnetic and inertial confinement maintain plasma states, but instability and turbulence lead to energy loss. Overcoming this challenge is important. Material requirement. Fusion demands materials that can withstand extreme heat and pressure, which is difficult to achieve. High energy requirement. Currently, the energy input for nuclear fusion is much higher than the output energy. Solving this inefficiency remains a key challenge. Why are nuclear fusion reactors essential for us? Clean energy production. Nuclear fusion produces no carbon dioxide emissions and generates minimal nuclear waste. Abundant fuel supply. Fusion relies on deuterium and lithium, which are abundant on Earth and can sustain energy production for millions of years. High energy density. Compared to any other fuel source, nuclear fusion can produce several tons of energy from just a few grams of fuel. Nuclear fusion presents a revolutionary solution to meet our present energy needs. In the future, its successful implementation will be a game changer for clean and sustainable energy. Support our mission to spread scientific knowledge to everyone by sharing this video. Don't forget to like this video and subscribe to our channel. See you in the next video. Bye bye.